Guys, let's talk about the Doppler effect for a second. And Doppler effect, if there was a bug on the water that was twitching a little bit but wasn't moving, the waves would come away from it. And how fast they come away has to do with the nature of the medium they're in, or the water. But if the bug was swimming through the water, the waves coming away from it, moving at the same speed, but now the bug is catching up to it in the direction that it's swimming. So if a bug is swimming this way, the Doppler effect is going to squeeze the waves together like here, and you're going to hear it, if you were to hear it, as a higher pitched frequency, lower pitched frequency here. What if it was a star and these were light waves coming away from it? Well, a star can be moving at an appreciable fraction of the speed of light. It's still tiny, but if you were looking at it here, the star would be, these would be pulled together, and the star, the wavelengths closer together, would be bluer. So the star would be blue shifted here. If you were over here and the star, if you were over behind it and the star was moving away from you, the waves being further apart would be then red shifted further apart from you that way. Great. So this gives you an indication of a way to test whether something is coming to or away from you. I'd like you to listen to the following clip here for a second, and I think you can tell what we're listening to and whether it's coming to you, and in fact, then when it's going away from you. Let's listen to that again. Ready? Here it comes. The frequency goes up. And right there when the frequency starts stretching out and gets lower, you could tell that the car, the race car in this case, has passed you. But if you hear a normal car passing you on the street, you could hear that as well. High frequency suddenly shifts over to lower frequency. Well, one of the other things that occasionally happens is that something moving on the water or through air is moving faster than the waves can get out of its way. Now, a boat on the water, even a relatively slow moving boat on the water, will drag itself in front of the waves coming away from it, and it will leave a wake. So any boat you see going at a decent speed on the water leaves a wake. And now if you're on the shoreline, what you'll see is these waves will hit one after another on the shoreline. Well, if this is an airplane moving faster than the speed of sound, the same exact thing occurs, except in this case, the wake is a shock wave of serious proportions. And you would be standing here, you would see this plane and not hear it. And then all at once, because all these waves are piled up on each other, instead of just hearing a constant sound, you would hear a sudden explosion of sound when it drags the wake by you. And this would be known as a sonic boom. And contrary to what most people think, that a sonic boom is created when something moves faster than the speed of sound, a sonic boom is simply dragged behind anything moving faster than the speed of sound. So if we had an airplane flying across the country faster than the speed of sound, it would drag behind it this sonic boom and would be very disturbing to people underneath it. That's one of the reasons why we do not allow air traffic in this country to move faster than the speed of sound in general. So that is the Doppler effect.